Alright, y'all ready? Okay, so yesterday we learned the log loop, we learned how to solve. Today we're going to learn some properties of logs. They have some kind of weird properties. We're going to learn how to expand today and then how to simplify tomorrow. So if you look top left, the first one is the product property. And the reason that it's the product property is because look inside the parentheses, what are x and y doing? They're being multiplied. That's x times y. So if you want to put a little dot in there, okay, those are multiplied together. Okay, so the way that you can split up a log of a product is that you'll do the log of x plus the log of y. Okay? The second rule is going to be the quotient property. And you'll notice that it's called the quotient property because what's happening inside the log, instead of multiplication, it's division. So take a guess. If products you separate into added logs, what do you guess you do when you're dividing? Subtract. You got it. So it'll be log x minus log y. Okay? And then the last rule is going to be the coefficient property. And this one is probably the weirdest one, but whatever exponent you have inside your log, it can move down to the front and turn into a coefficient. So your n, if it was x like to the power of n, will move down to the front, and then you'll have log of x. So that exponent that was up top is going to move down to the front. Okay? Now, the other thing, I forgot to write on all of these, but do you see the little b? Okay, so all of these would be that same base. So if this is a log base b, these would both be b's. And if this one was a log base b, both of the ones it splits up into, those would be base b's as well. So if you want to write that in there, technically each one of those should have a b. So when you separate a log, whether you're adding, subtracting, whatever, it's going to stay the same base that it already was. Okay? So we're going to run through just that top row here. Okay, log base 3 of 8x. Okay, that's going to split up into 8 and x right now are multiplied. So would it split up into addition, subtraction, or coefficient? Addition. So it'd be log little 3 of 8 plus log little 3 of x. And you're done. Okay, we're just practicing expanding these. Okay, look at number 2. Okay, 8 and x are now divided. It's 8 divided by x. How is that going to split up? So if they're multiplied, they split up into addition. And then if they're divided by, then they split up into subtraction. So it would be log base 12 of 8 minus log base 12 of x. Okay, and then remember that whatever your initial base is.
I need to do the notes from the work from yesterday.
Okay, it's on, I sent it under my note. Okay, then hang on 1 second and I'll get it for you. The papers, though, are right there.
Okay. These?
Okay, then look at number 3. Where did we say the 8 can move? If it's up top, then it can move down to the front, so it would be 8 log x. Now, the other thing I want to point out to you is that number 3 is missing a base. We talked about yesterday. What's the base if it's not there?
10.
10. Good. Okay, take a look at number 4. Okay, so these are going to basically just get more complicated as we go, but all you're doing today is breaking these down. So look at number 4. I'm going to do log base 3 of 7 plus log base 3 of x to the 4. So 7 and x to the 4 are multiplied. Well, then I can split them up into addition, but then I have one more rule that I have to do. Where can we move the 4? Down to the front. So that's really going to be log little 3 of 7 plus, and then 4 log little 3 of x. Okay? Alright, so now take a look at number 5. So this is where you have to start paying attention to kind of like order of operations. So when I'm doing number 5, I'm going to split this up first into 2x divided by 3. So I'm going to start off with 2 logs. I'll have log little 5 of 2x minus log little 5 of 3. Now, does it make sense why I'm subtracting those two? Because it was 2x on top and then divided by my 3. Good so far? Okay, from here, you're going to have to split this one up again. 2 and x are multiplied. That means they split up into addition or subtraction? Addition. So then I'm going to split this one up into log little 5 of 2 plus log little 5 of x minus log little 5 of 3. So basically, each number or letter that you see inside the log is going to end up getting its own log. So for example, when I'm counting here, I had a 2, an x, and a 3. Then at the end, you should have a log 2, a log x, and a log 3. So your goal is to simplify it all the way down to where each one has its own log. Okay, look at number 6. Okay, I want to separate the 16 and the y, but what is on the outside? The exponent. And remember, that exponent can move down to the front. So I'm going to bring my 3 down to the front. And then I'll have log little 12 of 16y. So the first thing I do is move the exponent and think about PEMDAS, right? What comes first? P-E-M-D-A-S, right? So that's why we move our exponent first. Also, it's on the outside. Then from there, 16 and y need to get their own logs. Will they be added or subtracted? Added. Very good. So it'll be 3 log base 12 of 16 plus log base 12 of y. Now, there's one thing that is wrong with this. Okay, when I look at that, who did the 3 initially apply to? Was it only the 16 like it is here? No, it was applied to both, right? So to fix that, these parentheses I had around the 16 and the y, they need to still be there when I split them up. Okay, these parentheses are telling me that both 16 and y had the 3 on the outside, so you want to be careful about that. Okay? And then one more thing, when you're doing your homework, I don't need you to show separate steps. If you can go from this to this, I'm fine with that. I don't need you to show each splitting up. Okay? All right, come down please to number 7. Okay, number 7, first thing I notice is I have division. I have x to the 2 on top, I have 5y on bottom. So I'm going to have log little 3 of x squared minus log little 3 of 5y. So far so good? So I do top over bottom. And then from there, I have a way that I can split up each of these guys. The 2 here can move down to the front. And then my 5y is going to be able to split up by addition or subtraction. Which one? Addition. Very good. So for this first one, I'm going to have 2 log 3 of x. Notice my 2 moved to the front based on that coefficient rule. And then minus. And then I'm going to split this up into 2 logs. I'll have a log 3 of 5 and then a log 3 of y. So log 3 of 5, log 3 of y. Now, this one is also a little bit wrong because initially, who was subtracted? Only the 5? The 5 and the y. So how can I fix it just like we fixed it on the other one? Put parentheses. Okay, and those parentheses do have to be there because they tell me that at the beginning the 5 and the y were both being divided at the beginning. Okay? Alright, so take a look at number 8. See if you can skip this middle step and then just go straight to the answer. So do number 8 real quick. Do you have an email that I can send the link to? Okay. Hang on and I'll get it from you. Okay, tell me your email, Tosh. TN331530 at g.rst. Okay. There you go. I sent you the link. Okay, so what you should have, I'm going to break it up just to make sure that you understand it, but check and see if you got it right. So it'd be A3 minus log 7b5. And then I would split this one by moving the 3 down to the front. And then I'm going to split this one up with addition. But you're going to need to put parentheses around it. Hello. Chase is not in class now. Okay, thanks. Okay, so then I would split up my log 7b5 into log 7, and then log b, and then instead of putting the 5 here, where can I move it? To the front right there. And then don't forget, you need those parentheses. Okay? Alright, turn over to the back. Got a couple more left. Okay, so the last thing that you need to know how to do for today is how to convert exponents into fractions. So there are really only 2 that you need to know. The first one is that if it's a cubic root, that's the same as a 1/3 power. And then a square root is the same as a 1/2 power. Okay, and so this is where that rule comes from, but do you see how the n is tucked into the elbow? That tells the type of root. Well, then that n needs to go on the bottom of the fraction that you use. But really, the only 2 I think you see on the whole notes is going to be a square root or a cubic root. So square root is a 1/2 exponent, cube root is a 1/3. So look at this first one. The first thing that I'm going to do is, because there's a square root, I'm going to make it a 1/2 instead. And when I convert that to a 1/2, where can it move? To the front. Very good. So I'm going to take my 1/2 from here, and I'm going to move it out of the way. So my 1/2 is going to be here now in the front, and then I just have log of 2x. And then how am I going to split up log 2x? Will my logs be added or subtracted? Added. So it'll be 1/2 log 2 plus log x. Now, who was originally inside the square root? Was it only the 2? Was both of them, so I need parentheses. Okay? Alright, go to number 10, same thing. I have a square root, that's the same as what power? A half. Then I move the half down to the front to get rid of it. So I'll have my 1/2 there in the front. Then it's a log 5v. And then to split up 5 and v, I would have to use addition. Also, you're going to need parentheses to show the 5 and the v were together. So it'd be log 5 plus log v. Easy? Okay, go down to number 11. Okay, look at your type of root. This one is a cubic root. So when I switch it to an exponent, it'll be a what? It'll be a 1/3. Good job. And then once I convert it to a 1/3, the reason we switch it is so that we can move it out of the way. So my 1/3 is going to come down here to the front, and then I'll have log little 7 of 5x. Okay, and then just like the other one, I can take my 5x, those are multiplied, I can split them up into addition. So it'll be 1/3 log base 7 of 5, log base 7 of x. And then big parentheses to show that both of them are in the house at the beginning, then they should both be in parentheses at the end. Okay, number 12 is basically the same thing, so I'm going to skip that one. Okay, go down to 13. Okay, we learned right before spring break, okay, and also in our lesson yesterday, that when an exponent's on the bottom, what do you do to it? You turn it negative. Okay, so look at number 13. I'm going to rewrite this like this. It'll be log 3, and then I'm going to keep my 2y, but instead of keeping it on the bottom to the 4, I'm going to switch it to a negative 4. Now, again, why does the exponent turn negative? Because it was originally a fraction. Okay? Then I can take the negative 4. If it's an exponent, I can move it to the front. So my negative 4 is going to go here in the front, and then I'm going to have log base 3 of 2y. So you shift the bottom up, turn the exponent negative, and then move it to the front. Okay, then from there, 2 and y can split up by addition or subtraction. Which one? Addition. So it'll be negative 4 log base 3 of 2 plus log base 3 of y. And then all of that in parentheses to show that they shared the negative 4 to begin with, and they should be sharing the negative 4 when they're split up. Okay? Last one, look at number 14. Okay, my term 5x cubed is inside a square root. What power is that? 1/2, but it's on the bottom. So when I rewrite it, what's going to happen to my 1/2? It's going to turn negative. Good. So I'll have log 5x to the 3 to the minus 1/2. And so again, the square root makes the 1/2 be there. The fact that it's a fraction is what turns it negative. And then from there, I'm going to follow my same steps. My negative 1/2 is going to move to the front because it's an exponent. And then my log is left over with a 5x cubed. And then I'm going to split that up. If it's 5x cubed, those are multiplied together, so I can split them with plus. So it would be negative 1/2 in the front, log of 5 plus log of x. Now, I could put the 3 here, but so that I don't have to rewrite it, where else could I put it instead of putting it up there? Down in the front, right there. Okay, so really, I'm going to cross this 3 out. It shouldn't be up there. It should have moved down to the front. And then keep your parentheses. Okay? Make sense? Okay, so tomorrow we're going to practice putting these together. Today you're just expanding them. So take a look at your homework. Okay, you just have a front side here. Let's do maybe like 2 of them just to get you started. Let's do number 4. Now on number 4, how many logs should you end up with when you separate that? 3. 1 for the 2, 1 for the x, 1 for the y. And if 2xy to the 5th are all multiplied, what signs should you be doing in the middle? What operation? Plus or minus? Plus. So it'll be log little 5 of 2, log little 5 of x, log little 5 of y5. Okay, am I done? No, what still needs to move? The 5 on top. So I'm going to take this, look, to not have to rewrite it, I'm just going to cross it out, and I'm going to put it in the front. And now you're done. Okay, why don't we do number 9? Okay, go down to number 9. How many things are inside the log on number 9? 3. So you should end up with how many logs? 3. Okay, so split it up. I'm going to do this one in 2 steps, but if you can do it in 1, that's fine. Okay, I'm going to do log of the top minus log of the bottom. That's going to be my step 1. I split it up top and bottom. And then after I split it up top and bottom, the next thing that I'm going to do is separate these guys from each other. So if it's a log 3b cubed, that's going to be a log 3 and a log b. Now, instead of putting the cubed here, is it okay if I just move it down to the front? So my 3 will end up right there. And then minus, I'll do my log a. And then instead of putting the 2 up top here, I'm going to put it down in the front. Okay? Okay, last one we'll do together. Look at number 10. Split it up top and bottom first. So it'll be log z3 minus log 4k squared. And then after I split it up top and bottom, I'm going to split those pieces up if I need to. So my top, I just have one thing to move. What is it? The 3 can move down to the front, so it'll be a 3 log z minus. And then just to make sure that I don't forget, I'm going to go ahead and open a parentheses here, because when I split up 4 and k, they were both on the bottom, then they both need to be with the negative. So it'll be log of 4 plus log of k. And then instead of putting my k squared here, I'm going to move it down to here. Because since the 4k squared was all inside here, when I split it up, I have to keep both of them subtracted. Now notice, okay, and this is actually something maybe where your question is coming from. Did I need parentheses when I split up the 3b squared when it was on the top? No, right? Because if it's on top, it's not being subtracted. You don't have to group them. The only time you would really need the parentheses is if you're splitting up a bottom. If you don't want to put parentheses, you could give each of them their own negative. If you prefer that, that would be fine. To show that the 4 was on the bottom and the k was on the bottom. Okay? But either one of those would work. Alrighty, yes ma'am. That is from yes. Okay, good job. So y'all have about 30 minutes to work on your homework.